So as a way to start thinking about what is happening here, what would happen if we took the derivative of each of these functions? So let's start with the first box. If I want to find f prime of x, what would we get? No, derivative. Just 2x, right? What happens to the 1? Yeah, because the derivative of a constant is just 0, right? It goes away. What about here?
2x.
Oh, that's weird. What about here?
2x.
It's also 2x. But you guys agree that each of the functions are different? Okay. So an antiderivative, do you guys remember if we were finding the antiderivative, we'd include a plus c. The plus c stands for just any constant because the derivative of a constant is just 0. It goes away. Okay. So when we're finding antiderivatives, we have to understand that the constant represents the c represents any constant because depending on the equation, you guys can see they're all different, right? If I took the antiderivative of 2x, we would get x squared. But notice in each of these functions, the plus c was different, okay? So what you guys are going to learn in this section is a general solution. Highlight this. A general solution of a function's antiderivative is the plus c, okay? But this represents what we're going to call a particular solution. So what you guys are going to learn in this section is if we were to integrate something like this, how do I solve and get 1? If that's the one that they're trying to get us to get, how do I know it's actually C is 1? That's what you guys are going to learn. Okay? So we've talked about definite integrals. Integrals without a boundary are called indefinite integrals. So understand that these are integrals if there's no bounds, if it's just blank. Okay? So in the past, we've been working with definite integrals when I do give you the boundaries because that helps us find the area under the curve. Now we will look at indefinite integrals, which means we're just finding an antiderivative. Cool. Now, there is something that I knew was going to come back. This is something that I skipped in the first semester because, to be honest, it doesn't come up that much. But because it's in these notes, I'm going to show you guys what it is now. But just know that if you guys don't remember the rule on the AP test, you're not going to fail the AP test because you guys don't know this rule. Okay, it's kind of weird. All right, exponential functions. This is something we haven't integrated yet. But just let's think in the forward direction. What would be the derivative of e to the x? Yeah, the derivative of e to the x is just e to the x. So if I go backwards, if I integrate e to the x, what do you guys think we get? It's just e to the x. The integral of e to the x is still e to the x. But since there's no bounds, what do I have to include? Plus c. That's easy. Okay. This is not the same thing. So this a stands for any number, 2 to the x, 4 to the x. This is an exponential function. So before we do the integral, let's do the actual derivative. That's what I did not teach you guys in the fall. Okay? The derivative of a to the x. You guys ready? Is going to be a to the x times, this is where it's weird. It's the natural log of a. So if this was 2 to the x, the derivative would be 2 to the x times natural log of 2. Done. That's it. Okay? So if I'm integrating, okay, going backwards now, the integral of a to the x would just be the same thing, a to the x. A to the x. But do you guys see how I'm multiplying by ln of a? So if I'm integrating, think about it as doing the reverse, going backwards. What's the opposite of multiplying? Dividing by. So it's going to be 1 over the ln of a times a to the x. Oops. But since there's no bounds, I have to include plus c. Hold on. My iPad freaked out. There we go. Okay. It's not that hard to remember, but it's just a weird one. To be honest, when I took Calculus 1 many moons ago, don't laugh. When I took it when I was in college, we didn't learn this until Calc 2. This is one of those things, just the AP people just love to make things complicated, so they throw it in AP Calc. Okay, questions on these antiderivatives? Okay, so problem number 1. Find the general solution of the integral of 7 to the x dx. So, what's my base? 7. So if I want to do the antiderivative, anybody want to take a shot at it? 1 over the natural log of 7 times 7 to the power of x. What am I forgetting? Plus c. Done. That's it. Cool. All right. So this is where the particular solutions come into play. If f prime of x is e to the x minus 2x squared, find the particular solution of f of x if f of 0 is equal to 4. So, do you guys agree if I take the derivative of this, I get this, f prime of x? So if I want to find f of x, what do I need to do to this function? What's going backwards of this? Take the antiderivative, so I need to integrate this. So I need to integrate this, and then we'll worry about this. Okay, so watch. F of x in general is the integral of f prime of x. Does that make sense? Because if I take the derivative of this, I get this. So I already know what this is. I want to go backwards, so I need to integrate it. So it's going to be the integral, let me zoom in, of whenever there's two things, I would put in parentheses just to make it look nice. E to the x minus 2x squared dx. Okay, so if I integrate this, what's the antiderivative of e to the x? E to the x. Wait, hold on. I gotta integrate this too. You're good. Minus, what was the rule?
2x cubed divided by 3.
Yes, 2x cubed, add a power, divide by the new power. Oops. Plus c. So this is the antiderivative, okay? Now, what this is going to allow us to do is find the function for this situation. So this is going to allow us to solve for c, okay? So f of 0 equals 4. I want you guys to think about that 0 is like the input, so that's going to be x equals, if I plug in 0 into this function, I get 4, okay? So using f of 0 equals 4, that means that 4 is equal to e to the 0 minus 2 times 0 cubed over 3 plus c. Is everybody cool with where that came from? Okay, this is nice because 0 cubed is just times 2 divided by 3, so we don't care. What is e to the 0? 1. Subtract 1 from both sides, and what's c? What? Oh, yeah, it's 3. Yeah, you're right. It's 3. I like standing in front of the room. I miss doing that, so whenever my iPad has enough juice, I'll do this. Okay, so c is 3. So that means that this was our antiderivative, right? Since we know c is 3, that means f of x is really e to the x minus this plus 3. That's our answer to this problem. So f of x is equal to e to the x minus 2x cubed over 3 plus 3. Okay, questions? No? Pretty good so far? Yeah. All right. Can I move on? Is everyone caught up? Okay. So this is something that we talked about on Friday. Do you guys remember what this was? ln of x, good. The integral of 1 over x is the natural log of x. But there's one thing that's important when we write our answer. Whenever you're taking a log, remember you want the argument to be positive. So when you do the antiderivative, it's the ln of the absolute value of x plus c. Okay, so to integrate this, what's the antiderivative of 1? X. Minus. Now, we know that 1 over x is ln of x when I integrate it. The only difference here is it's 5 over x. So it's like 5 times 1. Does that make sense? So it's just going to be 5 times this instead. So minus 5 ln of x, and then plus c. Is everybody cool with that? Okay, now same idea. If f prime of x is equal to 2 over x plus 6 over x squared, find the particular solution of f of x if f of 1 is equal to negative 7. So let's integrate it. We know what this is, hopefully, right? When I integrate it. But I'm going to rewrite this one just to make my life easier. So plus 6x to what power? Negative 2. So if I integrate 2 over x, what do I get?
2 times the natural log.
Yes, 2 times the natural log of the absolute value of x. Okay, plus 6x to the negative 1 over negative 1 plus c. That's okay. What? I didn't do it. Wrong number. Okay, so just to make our life easier, 6 over negative 1 is negative 6, right? But because I have this power like this, can't I just put the x on the bottom? So this will equal 2 ln absolute value of x minus 6 over x plus c. Okay, now, this is what we call an initial condition. Knowing that if I plug in 1, I get negative 7, we can use that information to solve for c. Okay? So that means that negative 7 is equal to 2 ln of the absolute value of 1 minus 6 over 1 plus c. Thank you. Is everyone cool with that? Okay. Assuming you don't have a calculator, what's the ln of 1? 0. So 2 times 0, so this is just 0, so goodbye. So negative 7 is equal to negative 6 plus c. Add 6 to both sides. C is negative 1. So don't forget to write your final answer as a function. So f of x is equal to 2 times the natural log of x minus 6 over x minus 1. Questions? Not too bad? Oops. Is everyone caught up? Okay. All right, now here comes some fun ones. So this is the way my brain works, so hopefully this makes sense. If I want to integrate cosine, my brain automatically says, okay, well, whose derivative gives me cosine? And what would you guys say? Sine, okay? The sine of x, if I take the derivative, I get positive cosine, right? Which is what we want in this case. So the integral would be sine of x plus c. Now, whose derivative gives me sine? Negative cosine, good. Because the derivative of cosine is negative sine, negative sine is positive sine. Okay? All right. Whose derivative is secant squared? Tangent. So this would be tangent of x plus c. Okay. Let's do this one first, because you guys probably remember this one more. Do you guys remember what this one was? Secant, good. So this would be secant of x. I can tell by the look on some of you guys' faces that you guys forgot what they are. Please don't forget what they are. Your AP test is now 3 months away. It's February now. Oh no. Okay, so this one's similar, right? This is where you guys say yeah. So what do you guys think this one's going to be? Cosecant, but the derivative of cosecant is going to give me a negative. So the integral of this is going to be negative cosecant of x plus c. Remember, all the co-derivatives are negative. Cosecant, cosine, which one are we missing? Cotangent. So this would be negative cotangent of x plus c. Cool? All right. Problem number 5. I really want to train you guys on this, especially when we get to U sub, because this will make your life easier. Trust me. Whenever you have a constant, what should we do with the constant? Take it out. So I could rewrite this as 3 times the integral of secant squared x dx. Whose derivative gives me secant squared? Tangent. So if I integrate this, this is going to be 3 times the antiderivative, which is tangent. So this is just going to be 3 times tangent of x plus c. Is everyone cool with that? Is anyone wondering in here, it's okay if you guys are, why don't I write 3c? Is anybody wondering that? Are you? For reals? Okay. What does c stand for? A constant, right? Does it matter what number it is? So if I multiply that by 3, is that going to change that it's still a constant? No. That's why we don't care that it's just c, not 3c. It could be negative 45. We don't care. Negative 112.2. We don't care. All right. Problem number 6. If dy dx is equal to 1 minus sine of x, find the particular solution of f of x. Technically, it should be y. This bothers me. Because if I differentiate y, isn't that dy dx? So they made a boo-boo. Okay. So same idea. Integrate this thing. So the integral of 1 minus sine of x dx. What's the antiderivative of 1? X. Now this one's tricky. Whose derivative would give me negative sine? Cosine. Is it going to be positive or negative? Positive. Good. X plus cosine of x plus c. And if you're not sure, you could, as these get more crazy, you probably don't want to do this, but the derivative of x is 1. The derivative of cosine is negative sine. So we did this correctly. Okay? All right. So now let's use the initial condition. So that means that this is my answer if I plug in pi for x. So pi minus 2 is equal to pi plus cosine of pi plus c. So let's leave this alone for right now. What's the cosine of pi? Negative 1. Good. So I want to solve for c, right? So do you guys agree I can subtract pi from both sides? And oh my goodness, they cancel. Add 1 to both sides. Bless you. So negative 2 plus 1 gives me? Negative 1. Yay. So y, not f of x, you silly sillies. Y is equal to x plus cosine of x minus 1. Okay. These next ones are the hardest ones to remember. Now, what's nice about these is talking to my homies that know things about AP Calc. This one rarely ever gets tested. So that being said, there's a problem that we're going to use right here for this one, but I've worked out the next like 4 homeworks and this one never came up. These two come up a lot. So if you're going to know any of these, it's going to be these two. Okay? So the derivative of arc sine, this is inverse sine, is this. 1 over the square root of 1 minus x squared. The derivative of secant inverse is 1 over the absolute value of x, square root of x squared minus 1. The derivative of tangent inverse is 1 over 1 plus x squared. So, trust me, if you're going to know any of them by heart, you must know these two. Okay, so that being said, 7's really easy. Which one of those is number 7? Sine inverse. So this one's just sine inverse of x plus c. Number 8, secant inverse of x plus c. Okay, I have, just trust me guys, I have a math degree. I don't remember ever learning that one. Ever. I do remember these coming up though. And working out your guys' homeworks, these ones come up a lot, okay? All right, number 9 and 10 are little tricks to make things easier, okay? So we're not actually finding a particular solution here. You're just making your life easier. So what I want you guys to notice is how many terms are on the bottom? 1. So you're not going to try to integrate the way it looks right now. What I'm going to do is I'm going to divide everything by x first, okay? So I could rewrite this like this. The integral, if I take 3x squared and divide it by x, what's that the same as? 3x. Plus, what's x divided by x? 1. Minus 2 over x dx. Now, this becomes so much easier to deal with. Okay, and this is important because you guys are going to learn something in the next section called use substitution. And when you guys learn that, you're going to want to do that to everything. No. We know how to do this, right? You guys don't even know what use substitution is, but do we have to use it here? No. So just be careful. All right. What's the antiderivative of this? 3x squared over 2. Good. Plus x minus
2 natural. Yeah.
Good. Plus c. Good. Don't forget the absolute values, guys. Otherwise, pi. 10. I have a function on the outside, right? So why don't I multiply? So before I do that, do you guys agree that square root of x is the same thing as x to the 1/2? Okay, so 3x times x to the 1/2 is going to give me 3x to the 3/2 plus 3x times x squared is 3x cubed. Now, take my advice. They both have 3's, right? So what are we going to do with the 3? Take it out. So this becomes 3 times the integral of x to the 3/2 plus x cubed dx. Okay. You guys good so far? All right. Now this next part is not that bad. Leave it like this. Don't feel like you guys have to rewrite it in a radical. And I'd actually prefer you guys to leave it as a fraction, because if you guys make a mistake, you're going to lose points on the AP test. So this is going to be 3 times the antiderivative. So add 1 to the power. What's that plus 1? 5 over 2 divided by 5 over 2 plus what? X to the 4th over plus c. Now, when I'm dividing by this, it's the same thing as multiplying this by what? The reciprocal, which is 2/5. Okay, so I'm going to do this in one step. 2/5 times 3 is going to be 6/5. So this is 6 over 5, x to the 5 over 2, plus 3 times this is just going to be 3x to the 4th over 4 plus c.